In this video, we're going to talk about linear and angular velocity. So first off, we're going to start by looking at a velocity graph that we have right here. So this velocity graph right here is showing that we're starting at a 0 time, and then as we're walking, our velocity is increasing. Okay, and we walk and we walk and we walk at an increasing pace. And then we get up here to where our velocity is constant. Then we start to slow down as our velocity goes down here, as it decreases. And then we go constant one more time. Then we go all the way and we start decreasing our time. And right here is where our velocity stops. So then what we end up doing is we end up turning directions and we speed up and go the other way. And then we start slowing down again because we're going to stop again. So once we stop there, we start increasing our velocity. And then we go back constant. And as we prepare to stop for the final time, our velocity starts decreasing. So velocity is just a rate of change. You can think of it as increasing and decreasing. When our velocity is positive and the graph is increasing, that means that our speed is increasing. When our velocity is decreasing or when our velocity is negative and decreasing, then our speed is also speeding up. So as long as it's increasing and positive, it's speeding up, or decreasing and negative, it's speeding up. But when it's opposite, so increasing and negative, or decreasing and positive, then that means our speed is slowing down. So that's what we have there. The main focus today is on linear and angular velocity. So linear velocity is what we are most used to. This is how fast an object is traveling on a circular path. Units are more conventional, such as miles per hour. Remember, we abbreviate miles per hour as mph. We have kilometers per hour, feet per second, etc., anything like that. Then we have our angular velocity, how fast an angle measure in radians is changing as an object moves on a circular path. These units are radian per some unit of time. So radians per second, radians per minute, radians per hour. So again, just to kind of show you a visual, you do not need to draw this. If I have this circular path right here, let's say I'm walking on a track. So let me make it more oval. If I'm walking on a track right here, okay, walking around the track is the linear velocity. But once we start to hit the curve from here to here, the angle at which this changes right here is angular velocity, or the rate at which that angle changes is angular velocity. So that's just to show you the difference. So some important numbers that we need to recall that we've already learned. If we go one full revolution, one full time around a circle, in radians, that would be 2 pi. In degrees, that would be 360 degrees. So what you need to know is that 2 pi radians is equal to 360 degrees. So those are important numbers. We're going to use those throughout this section or this lesson. Okay, now before we can actually get into the linear and angular velocity application problems, word problems that we're going to be dealing with, we need to understand how to do dimensional analysis. So what this is just allowing us to convert between different forms of units, because sometimes we're given inches, but we really want to find the miles. So just being able to convert from inches to miles, and this is the process we're going to do this from. So I have 3 miles. I want to know how many inches that is. So I start with my 3 miles, and I need to figure out what I can do to cancel out the miles. Well, I need to multiply it by something. Currently, 3 miles is over 1. So let me bring those down. So because I want it to cancel out, that means a miles needs to go on bottom. Well, in 1 mile, how many feet are there? Okay, well, that's something you're going to learn. There's 5,280 feet in a mile. So that converts the 3 miles to feet. Now, I need to figure out how many inches are in a foot. Well, again, I want the feet to cancel out because I want to be left with inches, so the feet need to be on the bottom because I have a feet on top. So, how many inches are in 1 foot? That would be 12 inches. And we know we're doing this correctly when all the units, except the one we want, cross out. So what I mean by that is I have a miles on top, a miles on bottom. They cancel out. Then I have a feet on top, a feet on bottom. They cancel out. I'm just left with inches, and that's what I'm looking for. So now all we're going to do is we're going to multiply everything that's left on top together and then everything that's on bottom together. In this case, everything on bottom is just 1, so you don't really have to worry about it. So we go to our calculator. We're going to go to a new document, add a calculator, and we're going to multiply 3 times 5,280 times 12. And again, we have nothing in the denominator besides 1, which is not going to change anything. So when we press enter, we have 190,080 inches. So that would be the conversion for this. So 3 miles is equal to 190,080 inches. And that is dimensional analysis. Looking at this next one, we have 45 kilometers per hour, and we want to convert it to meters per second. So what we have is 45 kilometers per every 1 hour. So we're going to pick which one we want to figure out first, because again, I need to convert kilometers to meters and then hours to seconds. So I'm going to start with going kilometers to meters. So I know I need to multiply it by something. And in order to cancel out my unit of kilometers, it has to be on bottom. So 1 kilometer is how many meters? Well, that would be 1,000 meters. That gives me enough to convert it to meters. Now I can focus on going from an hour to seconds. So I want my hour to cancel out, so it needs to be on top since the hour is originally on bottom. So in 1 hour, how many seconds are there? Or sorry, in 1 hour, how many minutes are there? There are 60 minutes. Okay, now I go from minutes to seconds. So again, I want the minutes to cancel out, so it needs to be on top. So in 1 minute, how many seconds are there? There's 60 seconds. So in the end, everything but the units we want should cancel out. So let's see if it does. We have our kilometers cancel out. Our meters cancel out. Oh, nope, we wanted meters, sorry. Our hours cancel out. The minutes cancel out. So if we look, we're left with meters per second. So now all I'm going to do is multiply everything in the numerator together. So 45 times 1,000 times 1 times 1. You don't have to multiply by 1. And then on the denominator, 1 times 1 times 60 times 60. Again, you don't have to multiply by 1 because it's not going to change anything in our value. So I'm going to start with my fraction button. I'm going to do 45 times 1,000. In the denominator, I have 60 times 60. I press enter. It gives me 25 over 2. I can also change that to a decimal. We need to make sure we know the fraction answer as well as the decimal answer. So if I change it to a decimal, I just hit Control Enter and I get 12.5. So in 45 kilometers per hour, there is 25 over 2 meters per second. Second can be abbreviated as just an S or sometimes an SEC. And then there's about 12.5 meters per second as well. So again, seconds can be abbreviated as SEC or as just an S. That would be our answer. So, and number 3, 7 revolutions every 3 minutes in radians per second. This is what you're going to see a lot of in this lesson. So 7 revolutions means it's going around a circle 7 times every 3 minutes. So it takes 3 minutes to go around the circle 7 times. So we have 7 revolutions over 3 minutes. I want to go to radians per second. Again, you get to decide which unit you want to get rid of first. So I'm going to get rid of the revolutions. So that means the revolutions need to go on bottom. So in 1 revolution, in radians, that is 2 pi. Now that I've gotten rid of those, I need to go from minutes to seconds. So again, I want to cancel out the minutes, which means my minutes need to go on top. So in 1 minute, how many seconds are there? There's 60 seconds. So I double check to make sure all my units cancel out except for radians per second. So revolution, revolution, rad, oh nope, we want the rad, minute and minute. So now all we do is we multiply across. So when we multiply across, I'm going to start with my fraction button. I have 7 times 2. I'm not going to type in the pi just yet, but when we get our decimal answer, I will. 7 times 2. On bottom, I have 3 times 60. So that gives me 7 pi over 90. Again, remember there is a pi up top that we did not cancel out. And in order to get the fraction, we cannot type in the pi. So we get 7 pi over 90. And our units would be radians per second. If I wanted to change this to a decimal, I'm going to take that fraction and multiply it by pi. On your keyboard, pi is at the bottom on the second row of your keyboard. So I'm going to take my previous answer and I'm going to multiply it times pi. And it gives me 0.244. Let's round to 3 decimal places. You do need to make sure that you're comfortable with rounding on these because on your test, you will have to round to whatever decimal place it tells you in the directions. And so these right here would be the answers. Okay, so that's dimensional analysis. Again, all that's doing is converting between different units of measure. Okay, the most important part of this topic right here are these 2 formulas. We have our angular velocity formula and our linear velocity formula. So looking at our angular velocity formula right here, we have some new symbols that we should get used to. This first symbol right here, it looks just like a W, but this is the lowercase omega symbol. And then we have theta, and theta is always going to be our revolutions times 2 pi. Revolutions times 2 pi, and then as expected, t is our time. For angular velocity, it will always be radians over time, always. Radians over seconds, radians over minutes, radians over hours, always radians over time. When we go to linear velocity, okay, linear velocity uses the v, And then it's r times omega. Omega is what we get for angular velocity. And then we have r, which is going to be whatever the radius is that we're given. And again, this right here is our angular velocity. So this next part that we're going through is super important, but these are the formulas that we're going to be dealing with throughout the rest of this video. So in example number 4, a ceiling fan makes 9 revolutions per minute, RPM, and each blade is 3 feet. Find the angular and linear velocity. So first off, on the side of your notes, you need to make note that anytime you see RPM, that is for revolutions per minute. That's something that we need to know right there. So we want to find angular velocity and linear velocity. I'm going to start with angular velocity. So angular velocity, I'm going to do in green. So the angular velocity formula is omega equals theta over time. So it's making 9 revolutions per every 1 minute. So I have my revolutions over my time, but I want it to be in radians over minutes. So I'm going to multiply by 2 pi radians over 1 revolution. So all I have to do is make sure that my revolutions cancel out. I multiply across. 9 times 2 pi is 18 pi. Let me go back to my color. And it would be radians per minute. If I wanted to write that as a decimal, we could type that into our calculator, 18 pi, and we get 56.55. 56.55. And again, having our unit of measure is super important. If you leave it off, you will not receive any credit when you take your quiz over this section. Okay, so that is the angular velocity. Now let's go into the linear velocity. So I'm going to do that in blue. So my linear velocity is my angular velocity times the radius. So the radius it gave me right here, that's r. Okay, each blade is 3 feet, and it's 3 feet from the center of the ceiling fan. So that would be 3 feet times my angular velocity, which was 18 pi over 1 minute. So on this step, we will always drop the radian. On this step, we will always drop the radians. Okay, so that's why I didn't write the radians. Linear velocity will always drop the radians. Okay, so when I multiply 3 feet times 18 pi, that gives me 54 pi. And my unit of measurement would be feet per minute. If I wanted to change this to a decimal, I would do I would get 169.6 feet per minute. You can pause this and type that into the calculator to make sure you understand how I got that decimal. But again, all I did was type it in the calculator, 54 times pi, and it gave me 169.6 feet per minute. Okay, let's look at example 5, and then we'll talk about the diagram that's above. So determine the angular velocity in radians per second if 7.3 revolutions are completed in 5 seconds. Okay, so we want to find the angular velocity. Angular velocity is the following formula. We have omega, which is equal to theta divided by time. So what it told us is that it's making 7.3 revolutions in 5 seconds. So we have the revolutions over seconds. The only thing we need to do is convert it to radians. So in 1 revolution, there are 2 pi radians. This allows us to cancel out the revolutions. Then we just multiply across, and we get, because it's already given to us in a decimal form, the 7.3, I'm going to write this as a decimal. So 7.3 times 2 pi divided by 5, that would be 9.2 radians per second. Again, if you need to double check this, please type this in the calculator, double check it to make sure that we got the same answer and you know how to type it in. So now, what I've hoped you gain from those 2 examples is that you're able to see the pattern. If you're given a revolution and you want to go to angular velocity, all you have to do is multiply by 2 pi. If you have angular velocity and you want to go to linear velocity, all you have to do is multiply times the radius that you're given. If we're given linear velocity and we want to go to angular velocity, we just do the opposite and we divide by the radius. If we're given angular and we want to go to revolutions, we're just going to divide by 2 pi. So whether you prefer the formula or this little chart, whichever one helps you most, that's what you need to remember. These formulas are not on your reference sheet, so this is something you are expected to just know. You cannot find linear velocity if you're given the revolution without finding angular velocity first. So just keep that in mind. Again, whichever one makes the most sense to you. So we have 3 more examples that we're going to go through real quick. Again, if you need to pause at any time, make sure that you pause and you are comfortable with the calculator. So here we go. Determine the linear velocity in centimeters per second of a point rotating at 7 pi radians per second at a distance of 5 centimeters from the center. So we want to find the linear velocity. So that's going to be v. So that would be our radius times our angular velocity. So we are given the radius right here, 5 centimeters from the distance of the center. And then we need to multiply it by the angular velocity. And this is where you have to be careful. What they gave us is radians per second, so you have to understand that that is our angular velocity. That is W. So there's no needing to find W or omega. Okay, so that would be 17 pi. And remember, when we're finding linear velocity, we just drop the radians per second. So when I multiply those across, 5 centimeters times 17 pi, that would be 85 pi over 1, which you don't have to write, but our units are centimeters per second. If we wanted the decimal version of it, we would do 85 times pi, and we would get 267.04 centimeters per second. Again, the units of measure are super important. That is the big part of this. Without them, you can't get any credit for these types of questions. So there we go. Number 7 A cylinder with a 2.5 radius or foot radius is rotating at 120 RPMs. Remember, we said that that is revolutions per minute. We made that note up top by example number 4. So we want to give the angular velocity in radians per second. So that would be omega equals, or W equals, again, it gave us 120 revolutions for every 1 minute. So I'm going to convert the minutes to seconds first. So if I want to cancel out the units of minutes, it needs to go on top so it can cancel out on bottom. So in 1 minute, there's 60 seconds. And then I need to make sure that I convert it from revolutions to radians. So if I want the revolutions to cancel out, I need the revolutions to go on bottom here. So in 1 revolution, there's 2 pi radians. So we know we did this correct if everything ends up canceling out except the radians per second. So if I look, revolution, revolution, they cancel out, minute, minute. I'm left with radians over seconds, so everything is good. We're going to multiply across. So when you type this in your calculator, you start with the fraction button. You're going to multiply 120 times 1 times 2. And then in the denominator, just over 60. So when we do this, it should simplify to 4 pi. And again, that would be radians per second. If we wanted the decimal version of this, that would be about 12.6 radians per second. And that would be it. In part B, it says find the linear velocity of the point on its rim in miles per hour. So we found radians per second. Now we want to use the linear formula to find miles per hour. So remember, the linear formula is the radius times the angular velocity. The radius is 2.5 feet times the angular velocity, which is 4 pi radians, which again, we can drop the radians because we're going to linear form per 1 second. So again, pick which one you want to convert first. Do you want to convert the feet or the time? If I want to convert the feet first, that means that in 1 foot, that means the feet need to go here, and I'm converting it to miles. So in 1 mile, there's 5,280 feet. Now that I've done that, I can focus on going from seconds to hours. So if I'm looking at this, I want to cancel out the seconds. So seconds need to go on top, which means minutes will go on bottom. In 1 minute, there's 60 seconds. But I need to convert it to hours, so I need to cancel out the minutes, which means this needs to go on top here, and hours need to go on bottom. In 1 hour, there's 60 minutes. So now I double check to make sure everything cancels out. So feet on top, feet on bottom, seconds on bottom, seconds on top, minutes on bottom, minutes on top. I'm left with miles per hour, and so now I can multiply. In my numerator, it's going to be 2.5 times 4 pi times 60 times 60. In the denominator, it's going to be just 5,280. So if we didn't type in the pi, we would get 75 pi over 11 miles per hour. If we typed in the pi, we would get 21.4 miles per hour. In our last example, the tires on our car have a diameter of 30 inches. If the tires are turning at a rate of 200 or 2,000 revolutions per minute, determine the car's speed in miles per hour. Okay, that means linear velocity. So what you have to be careful of is that it gave you the diameter and we need the radius. What we also have to find is the angular velocity. So step 1 is we're going to find the angular velocity. It says that it takes 2,000 revolutions for every 1 minute. So if I multiply that by 2 pi over 1 revolution, that gives me my angular velocity. And again, my revolutions cancel out. And so it goes 4,000 pi radians per minute. But that's not what I want. I want the linear velocity in miles per hour. So that would be my radius times my angular velocity. I was given a diameter of 30 inches. Half of that is my radius. So that would be 15 inches times the 2 pi over 1 minute. And again, this is where we decide what we want to cancel out. That's not 2 pi over 1 minute, I'm sorry. 4,000 pi over 1 minute. So I need to convert the inches to miles and the minutes to hours. So we're going to start with the inches. If I want to cancel out the unit of inches, it needs to go on bottom and feet's going to go on top. So in 1 foot, there are 12 inches. Now I want to go from feet to miles. So if I want to cancel out the feet need to go on bottom and miles need to go on top. In 1 mile, there is 5,280 feet. Then I want to cancel my minutes or change my minutes to hours. So my minutes is on bottom, which means my minutes need to go on top to cancel out. Hours can go on bottom. So in 1 hour, there's 60 minutes. And now we just make sure everything cancels out. Inches on top, inches on bottom. Minutes on bottom, minutes on top. Feet on top, feet on bottom. If I look and make sure I have miles per hour, no other units left. So I'm going to multiply. When we multiply on the top, 15 times 4,000 times 60. And on bottom, we're going to multiply 12 times 5,280. When you do that in your calculator, it should give you 625 pi over 11 miles per hour. As a decimal, that would be 158.5 miles per hour. So the first answer, I did not type in the pi in the calculator. The second answer uses the pi in the calculator. So if you have any questions, please use any free space to write them down to make sure you ask them in class. That's it for this lesson. Again, if you have questions, make sure you ask in class.